So let's get into this quickly. And almost every use case has some application of machine learning, right? You want to predict a customer lifetime value from your CRM data, or you might want to run recommendations for your users in e-commerce, or recommendations in an educational site. You might want to determine churn, people leaving uh, your gaming website, where if you are not able to detect that churn, you might not be able to project what your returns would be in the future, right? And of course other use cases around time series forecasting and so forth. Every industry has a potential to run some kind of machine learning use case, and from an AutoML perspective or HeatWave, we have a wide variety of coverage, right? So one is, of course, anomaly detection. So whether it is log anomaly detections or anomaly detections and other kinds of data sets which might identify, possibly fraud. Then there is, of course, classification. And then, of course, the most commonly used, especially in e-commerce, recommender systems, right? So people who bought this also bought this, and you may like this, and so on and so forth. And typically in supply chains, you'd want to estimate what your stock should be, how much of your stocks are going to get depleted. That's part of the domain that covers time series forecasting. So we cover a large variety of use cases, and when I'm saying things like anomaly detection or time series forecasting, it's not just one type of model that we support. There are multiple types of models that are supported. For example, you can do regression with XGBoost. You can do classification with XGBoost, both of which are supported. Same goes for time series forecasting. There are multiple time series forecasting models like Arimax or even exponential smoothing. All of those are again supported within the machine learning capabilities within HeatWave. So let's see why AutoML on HeatWave makes sense, right? So almost all of your data tends to be within your database, and if you want to run a machine learning workflow, it would entail things like data pre-processing, selecting algorithms, creating samples, selecting your features and hyperparameter tuning and all of that, right? And eventually, of course, you want to train your model and then run predictions on top using that model, right? So with AutoML, what we are able to do is we do all of these capabilities right inside of your database, right? So you won't have to replicate your data from your database to your object storage and load it into another system where it will then run training. You'll probably do some data pre-processing and all that, create a model, right? And create a model catalog where you'll store the model, and then you'll run the model from there, right? Instead of that, what you have is all of your training data is right within your database. You can train your model within your database. So security, integration, workflow, all of that can be managed internally without ever worrying about where my data is, whether it's secure, whether it's getting secure whether data transfer is secure, whether it is is there security of data at rest. All of those worries go away because it's just there in the database. And once you create the model, you can also host the model within the database. You don't have to move the model out, right? So you can host the model within the database. Any new data that comes in, the model can create predictions for it. So that's the idea behind AutoML. So this is essentially what we were describing, right? So it eliminates a lot of laborious work where you're moving data from one system to another. You have an interface that you're familiar with, right? With the SQL, and the best part is, even if you're a novice machine learning engineer or or you're a hobbyist, for example, right? So you don't have to worry about which algorithm to select. So if you do not specify the algorithm, HeatWave actually, for example, trains your models on all the possible algorithms and finds the best algorithm for the parameter that you have decided for evaluation, right? So based on that, a particular model is selected, a particular trained model is selected, and that's the one. If you're an experienced data scientist, you'd want more control, and HeatWave doesn't actually take away control from you. So while we have sensible defaults, we also have the ability where you can actually take control and tweak things to get the kind of model you're looking for. We have built in the capability of explainability, right? So explainable AI is a big thing, especially in regulated industries, where for every prediction that you make, you might want to provide a justification, and HeatWave provides that capability as well. ML can be run on data, not just within your database, but also from object store, simply because of the lakehouse and runs how you could load data from your object storage into HeatWave, and then you can actually essentially use that data for training new models. So here's an example, right, where a user, based on a user profile, a recommendation system actually recommends restaurants, and based on inputs from the user, you are able to with generative AI actually, kind of reduce the number of choices to very specific choices, right? So this user has, probably tried different kinds of restaurants and has certain preferences. But when a specific request comes in from the user, the menus that are stored in the vector store are used to determine which of the restaurants that the user has preferred previously have these kinds of items, right? In this case, of course, vegan items with tofu. And then you combine the both of them, look at the intersection of the restaurants' recommendations and restaurants that have tofu, and come up with an intersection of that set and provide the results. So you can use machine learning and generative AI in combination to give you some amazing results. Here's essentially how machine learning works. It's very straightforward and very simple. The first thing you have to know is a stored procedure called ML train. It's in the sys schema, and ML train takes things like the feature column set, the training table, the task that has to be accomplished. Now, I'll show you. In this case, they've come up. The example shows a recommendation, which means that this is a recommender system, and then item based. Depending on user based or item based, you can choose what kind of recommendations you want. You have to specify certain options based on which ML train will use your feature set and train a new model. You can score a model, see how it's performing, and decide based on that whether you want to go with that model. Typically, a lot of classification models tend to be you want to score. We spoke about explainability, and explainability is where you can explain the importance of every feature for every prediction that is made by the model, right? So if you have certain features, let's say age or gender or something like that, that affects the choices that the model makes, the model will give you an estimate of how much every feature affected the prediction. Okay, the prediction itself, right? So you can either predict row by row, so there'll be predictions for a specific row if you want, or you can do predictions across an entire table. Okay. So like I said previously, you can have a combination of machine learning and generative AI to come up with ideas. So here, what you see is an error log or a log, and we've detected some anomalies in that thanks to AutoML, and that goes in as context for the generative AI model. And also, there are certain searches in the knowledge base where there is a history of previous issues, white papers, bugs that have been reported. And using that, generative AI can come up with recommendations about how to handle certain types of issues that have been detected in the logs. So here are a set of discovery questions, and you want to know what kind of machine learning use cases customers are looking to implement. Whether they are even using machine learning, are they in that stage of maturity where they are using machine learning, and what kind of technology they use. So these will give you a sense of where the user stands, okay, and help you discover and qualify opportunities. So I'm going to just jump quickly into a setup to show you a simple case of forecasting electricity demand, right? So I hope you can see my screen. So I'm going to log into, so I'm going to show all of this in the back end, and hopefully that should suffice. So I'm just going to create a new database for all the data that I'm going to create for this. So very simple: date, demand, temperature. Based on temperature and the day of the year, you probably get some demand for electricity in a particular region, and we're just going to use some dummy data that we'll use to populate, and so we have 48 rows of this data. We can say star from electricity demand and say limit 3. I should, okay. So you can see. So there's a temperature, there's electricity units demanded, and the day of the year. Okay. So the first thing we want to do, of course, we want to split this data into training and test data. So we're going to create the training data. This is what this looks like. And we're going to create some test data. So now we want to create a model handle. So this is how we will access the model in this session. So this is this, and we are going to give the model variable name, a model handle name. And then we are going to run ML train on this. As you can see, ML train is, of course, going to use the training table that we created. We are specifying the task. What we want to predict is demand. And we are saying that where could we get the timestamp for this is in the date column, where the date column is. So we got the date column, and we're saying endogenous variable. This is a very data science thing, and there are exogenous variables, endogenous variables, and that is a whole field within time series forecasting, and I'm not going to touch upon that. But essentially, we want to run this to train a model that will predict demand, right? So we're running this. This training is going on, and let's see. Okay, so the training is done. So we must have a model by now. So we had the model handle forecasting use case. Let's see. So we have a model. We have a model ID. We have a model, and we also know what the training table name was. Okay. Now, before we use this model, we have to load it. Okay, and so this is how we're going to load this model. Essentially, this is going to take some time depending on the size of the model, and then we are going to run predictions. So here's the idea. This is predict table, we are calling, and we are using the test table here. Remember, we have not used the test table. We are using the model that we created just now, and we are creating a new table called predictions. Okay. And you can actually go through the documentation. There are a lot more options that can be used, and that can be used to tune the way your model behaves, the way your model predicts, and all of that. So here are the predictions, right? This is the demand that's projected for power, right? So let's say I want to score this model and see how it's performed, whether we want to change this model, whether we want to use another algorithm, whether we want to change something in the options that we provide when we train to get a better model. So this is what you would use. You specify that you want to score, and you specify a metric that has to be used to determine how this model has performed. So absolute percentage error is what we are using here. So this, I think this is, I don't know, maybe okay. I'm not a data scientist, so I'm not in the best position to say what is good and bad for a particular use case. But here's the thing, right? So now we are done, and we want to unload the model. If you want to see how a classification model behaves, this is an example of someone who might want to, pay a monthly bill, and we want to see whether this person would be able to pay. So we're looking at the balance, the education, the age, whether the person has a telephone, whether the housing loans, what is the balance, and what is the level of education. And based on that, you can see that the probability changes of yes and no. You can actually specify a threshold. In this case, I think we've taken like 50% or something. And if there is anything that says that the probability is yes, more than 50%, we say that the prediction is positive, right? So this is a classification model. As you can see, things change as we change the features, so the predictions are different. Based on the predictions, we can decide, maybe take some business decisions. So that's that.